Segment 3, Studying the Stars. Before watching Studying the Stars, think about this. How did the invention of the telescope provide information about our galaxy? Humans have been looking to the skies for a long time. It began simply, perhaps in wonder at the mysterious specks of light that punctuated the dark night. In time, humans connected the stars and planets to figures of myth. We followed their movements to predict harvest and create calendars. Throughout our history, they've compelled us to wonder what else and who else is out there, and they have inspired us to seek the answers.
The first time I saw the Milky Way, I looked up, and it was not just a cloud. As you pan across the Milky Way, you see the stars that comprise this glow of light that crosses the sky, and it can change you for life.
Galileo Galilei was one of the first astronomers to look at the sky with a telescope. His discoveries rewrote thousands of years of astronomy.
What we see in the sky is the same thing that Galileo saw, and the reasons that we look, the reasons astronomers look in the sky, are the same reasons that Galileo looked. He was trying to find out what was happening out there.
Galileo's telescope was the first of many we would use to study our solar system and the stars and galaxies beyond. It's one of two types of what are called optical telescopes, which gather light from celestial objects to produce an image. The optical telescope Galileo used was called a refracting telescope. It uses lenses to collect light. Refracting telescopes are still used today. But since large lenses are difficult to produce and maintain, they are no longer the most popular. That distinction belongs to the second type of optical telescope, invented by Isaac Newton. Called a reflecting telescope, it uses mirrors rather than lenses to collect light. Large mirrors are far cheaper and easier to make than large lenses. As a result, the world's largest optical telescopes, including the Hale on Mount Palomar in California, are reflecting telescopes. This telescope has a mirror measuring 5 meters in diameter. But no matter how powerful our optical telescopes get, much of our universe will always be invisible to them. They can only detect visible light, the electromagnetic waves that we can see with our eyes. But visible light is only a small part of what's known as the electromagnetic spectrum, the full range of energy waves that radiate through space at the speed of light. Each part of the spectrum can tell us something different about the universe, and we usually use a different kind of telescope to study each part. Starlight normally reaches our eyes as white light, a combination of all the colors in the visible spectrum. With a device called a spectroscope, scientists can separate this light. The reds, oranges, blues, and violets from a star or planet can then offer clues about their temperature and chemical composition. They can even tell us if a star or planet is moving toward Earth or away.
It's just like the pitch of a car engine, you know, as a car goes zooming by, you hear the engine kind of go, With light, when something's coming toward you, the spectrum gets shifted toward the blue. When it's going away, it gets shifted toward the red.
Radio waves are the longest waves in the electromagnetic spectrum, which means they require the largest telescopes. The VLA, or Very Large Array Radio Telescope in New Mexico, uses 27 dish antennas to scan the skies for radio signals. Those signals are then combined and converted into pictures. These telescopes are used to measure some of the most active objects in the universe: quasars, novas, supernovas, and pulsars.
If you're listening to the universe with a radio telescope, it would mainly be a hissing sound. It sounds like steam escaping from a radiator.
Radio telescopes have helped us learn about the development of stars, the origin of the universe, and our place in the Milky Way galaxy. As for the rest of the electromagnetic spectrum, scientists have developed special equipment that can detect wavelengths of different lengths. Infrared, ultraviolet, and X-ray radiation get muddled in Earth's atmosphere, so we have to bring our telescopes to them. The best place to collect this information is in space.
For our work, we need a telescope out in space because what we're after is a certain kind of star. And we have to be able to detect that kind of star against the background of a galaxy. And the Earth's atmosphere smears and blurs our view, and we can't detect those stars.
Orbiting X-ray telescopes such as NASA's Chandra allow scientists to study objects with extremely high temperatures, reaching millions of degrees Celsius. Objects such as supernova explosions, neutron stars, and black holes. On the other hand, infrared space telescopes can measure much cooler objects, from the icy surfaces of planets and asteroids in our solar system to the dusty interstellar clouds where stars form. These objects range in temperature from near absolute zero, about minus 273 degrees Celsius, to just a couple of thousand degrees. The Cosmic Background Explorer, or COBE, measures diffuse infrared and microwave radiation left over from the Big Bang and our early universe. Ultraviolet telescopes, such as the one on the spacecraft SOHO, give astronomers dazzling views of our sun. The Hubble Space Telescope, a type of reflecting telescope, is the largest telescope ever sent into space. Launched in 1990, Hubble has helped prove the existence of black holes, offered evidence suggesting the universe is expanding, and revealed unprecedented views of how a star is born, and also how it dies. Our quest to learn more about the universe is never-ending. Over the last few decades, we've sent many spacecraft equipped with instruments that interpret the entire electromagnetic spectrum out of Earth's orbit to send back close-up looks of our celestial neighbors. Spacecraft such as Voyager 1 and 2 have discovered and captured these images of active volcanoes on Jupiter's moons, winds on Saturn, and a tornado on Neptune. Scientists are hoping that images from this spacecraft will give them their first close-up look at interstellar space. Thanks to our extended eyesight across the electromagnetic spectrum, we can see the light of billions of stars in the sky. The light that enters our telescopes offers us more than an understanding of our universe. It's an explanation for where we came from and where we might be headed. Now that you've seen Studying the Stars, talk about this. What is an optical telescope? Describe the difference between a refracting and a reflecting telescope.